Hello. So in this lecture, we are going to see the state equation of ideal gas for reversible adiabatic process, and we are going to prove this equation PV to the power gamma equal to constant, which a very famous equation is used for state regulation of adiabatic process. So in this, what is gamma? Gamma is specific heat ratio. That means Cp by Cv. तो इस प्रूफ करने के लिए फर्स्ट वी नीड टू नो द फर्स्ट लॉ ऑफ thermodynamics. That is, from first law of thermodynamics you can write dq, that means heat given to the system will be distributed in delta u, that means internal energy, and work done, dw. So you can also write this as, since uh, this is an adiabatic process, no heat will be exchanged with the surrounding, so dq will be 0. So you can write this as du, which will be equal to minus of work done. And we also know that here du is, for this process, du will be n cv dt. This is for any kind of process, and dt better you can write capital T, so that will represent change in temperature, which is equal to dw. Work done here will be pdv, we know from this formula. So when you keep this in RHS everything, or LHS in one side, so you will get pdv plus ncv dt equal to 0. This is the first equation we got. Now, since there are so many variables here, we need to find one more equation for this, which can be found out from ideal gas equation itself. So PV equal to nRT from ideal gas equation. This is from ideal gas equation, PV equal to nRT, and everything is in differential form. In first we got everything in differential form. Let us differentiate this equation. So UV rule we will use to differentiate. So P into differentiation of first term plus V into differentiation of second term will be equal to nR is a constant. So differentiation of right hand side will be dt nR dt. So from here we got the value of n dt is equal to p dv plus v dt by r. This is the second equation. Now we'll put the value of n dt in first equation. So putting equation 2 in equation 1. Putting equation 2 in equation 1, what we will get? If we put equation 2 in equation 1, we will get here p dv as it is you can write, plus cv you can write, n dt. N dt can be written as, from here, p dv plus v dt by r equal to 0. Now let us simplify this equation further. When we simplify this equation, you will be getting p dv plus cp. Let us multiply this inside. You will get cv by r into p dv plus cv by r into v dt equal to 0. Now let us take pdv and pdv common from here. So we will get PdV if we take common. We will be getting 1 plus Cv by R, and here we will be getting Cv plus R is equal to Vdp equal to 0, right? So further, if you write this equation, if we further simplify this equation, we will be getting let us take LCM R. So you will be getting R plus Cv by R, which is equal to plus here Cv plus R Vdp equal to 0. Now R plus Cv we can write from Mayer's relation. We know Cp minus Cv equal to R. This is from Mayer's relation. We'll be using here this Mayer's relation, and what we will get from here, that means Cp will be equal to Cv plus R. That means Cp plus R, we can substitute Cv here. So this complete quantity can be substituted as Cp from here, Mayer's relation. If we substitute here, we'll get PdV plus Cp by R plus Cv by R Vdp equal to 0. Now we can take R common here. If we take R common from here, we will be getting an equation something like this: 1 upon R is equal to PdV into Cp plus Cv into Vdp equal to 0. Now this quantity cannot be 0 because we know its value is positive, so this quantity has to be 0. So we can write Vdp into Cp plus V Cv dP equal to 0. Now if you take this in another side, you will get Vdp is equal to Cv into Vdp, and this Cp is also here. Cp equal to minus we will be getting here. Now further, when we write this as you can put this Cv here, you can bring this Cv in left hand side, we will get Cp by Cv equal to minus of Vdp. Cp by Cv you can write as gamma. This is just adiabatic ratio or specific heat ratio. So Vdv will be gamma equal to minus of PdV gamma into Vdp. Now let us separate dV and V one side and dP another side so that we can integrate. Now we can write dV by V. We can bring this V this side. Gamma already is here. Is equal to minus of dP by P. P, if you bring this side, it will come down. Now if you want to remove this dP and dV both sides, what we have to do? We have to integrate both sides. And integration will be from V1 to V2. Means this adiabatic process is brought from P1 V1, and adiabatically it is brought to another state of gas, that is P2 V2. So initial is this one is initial and this one is final. So lower limit we will put initial, that is volume is V1, and final volume will be V2, and here initial pressure is P1 and final pressure will be P2 here. So when you integrate this, we will be getting, after integration, we will be getting ln V. integration of dv by v will be ln v. You know integration of dx by x is ln x, ln x या ln x भी बोल सकते हैं. So gamma into ln v from v1 to v2 is equal to minus of ln p from p1 to p2. Now when you substitute v1 and v2 here, you will get gamma ln v2 minus ln v1. First we will put upper limit, then we will put lower limit. Then here what we will be getting, ln, first we will put upper limit, then lower limit, ln p1. Now further, when you will simplify this, we will be getting here from, that means using property of ln xy minus ln y is equal to ln x by y. So if you use this here, you will be getting gamma ln v2 by ln v1 equal to minus of ln p2 by ln p2 by p1. Okay. So this is what we have got. Now you can using the property of log, that means log ln a to the power b is equal to b ln a. That means b ln a can be written as ln a to the power b. So this gamma we can write in terms of power also. That means ln v2 by v1 to the power gamma will be equal to minus of ln p2 by p1. Now if you bring this, or you can use this minus sign also, that means ln a to the power minus 1 will be minus of ln a similarly. So this property we will be using here, this minus sign you can put this side. So ln v2 by v1 to the power gamma equal to ln p2 by p1 to the power minus 1. So further if you simplify this, we will be getting ln v2 by v1 to the power gamma will be equal to, let us take reciprocal of this, p1 by p2. So when you take anti-log of both, what you will be getting? Since in order to solve this equation we have to take anti-log. So anti-log of this, that means you can write here v2 by v1 to the power gamma will be equal to p1 by p2. So if you multiply this equation, cross multiply, you will be getting p1 v1 to the power gamma. This will be multiplied this side and this one will be multiplied this side. You can write p2 v2 to the power gamma. So this is the relation which we wanted to find out. So if these two are equal, we can write that for any initial and final pressure, it will be pv to the power gamma is equal to constant. This is a relation which we have to find. So this is the final result for this